Ever pondered how robot arms calculate movement? It's not magic, it's science. The graceful arcs and precise movements of a robotic arm may seem effortless, but behind the scenes, there's a world of complexity. The robot doesn't just move. Every motion is the result of intricate calculations, advanced algorithms, and precision engineering. Imagine trying to pick up a glass of water. Your brain automatically calculates the distance, adjusts your arm's angle, controls the grip of your hand. Now imagine programming a robot to do the same. It's not as simple as saying, pick up the glass. The robot needs to know where the glass is, how heavy it is, how to adjust its grip without breaking it. These seemingly simple tasks become a series of complex problems that need to be solved. The arm's movement isn't just mechanical, it's mathematical, it's computational. It's a symphony of science and technology working in harmony. So let's delve into this fantastic world of robotics and unravel this mystery. The first step in the dance of a robot arm is the blueprint, also known as the kinematic model. Now, what exactly is a kinematic model? It's a mathematical representation of the robot arm's physical structure. This model is like a roadmap that guides the robot's movement. It includes every joint and link in the robot arm, each with its own unique role in the dance. Imagine it like this. If the robot arm is an orchestra, then the kinematic model is the sheet music. Every note, every pause, every crescendo is meticulously documented. Similarly, the kinematic model gives a detailed account of each joint's range of motion and each link's length and orientation. It's the robot's understanding of its own structure that makes this all possible. It's as if the robot arm has an internal mirror, reflecting its own form. This self-awareness allows the robot to calculate precise movements. It's a fascinating process. Armed with this knowledge, the robot arm is ready to plan its moves. Now that our robotic friend understands its structure, it's time for the choreography of calculations. In order to move, the robot arm uses a process called inverse kinematics. This might sound like a term from a sci-fi movie, but it's actually a crucial part of how robots calculate their movement. In simple terms, inverse kinematics is the method by which a robot determines the necessary joint angles to reach a specific position. Imagine a dancer planning their movements across a stage. They don't think about every single muscle movement. Instead, they focus on where they want to end up, and their body calculates how to get there. That's similar to how robots use inverse kinematics. They know the final position and they calculate backwards to find out the necessary movements. Now, let's dive a little deeper. The process of inverse kinematics involves complex mathematical algorithms. These calculations are like the choreography for a robot's dance. They determine how each joint and limb should move in order to achieve the desired position. And just like a world-class dancer, the robot must execute these calculations with precision and grace. From a human perspective, it's like solving a multivariable equation in real time. For a robot, it's just another day at the office. Even the most intricate movements are broken down into a series of calculations that guide each step of the process. With these calculations, the robot arm can execute its moves with astonishing accuracy. Finally, it's showtime. The dance of the robot arm begins. Imagine a ballet dancer poised and ready. Each movement is calculated, each gesture precise. This isn't so different from how a robot arm operates. The process begins with the implementation of calculated movements. These calculations, as intricate as the steps of a ballet, guide the arm through each of its tasks. But the beauty of the robotic arm is not just in its initial programming. No, the true elegance lies in its ability to adjust and adapt in real time. Here's where the magic happens. Feedback from sensors is continually relayed back to the robotic arm. These sensors act as the arm's eyes and ears, providing real-time data about its surrounding environment and its own position. This constant stream of information allows the robot arm to adjust its movements as needed, ensuring each motion is smooth and precise. Just like a dancer adjusting to the rhythm of the music, the robot arm adapts to the information it receives. It's a complex dance of data and movement choreographed by calculations and algorithms. The result? A dance that is as mesmerizing as it is precise. A dance that is as fluid as it is calculated. A dance that is, in essence, a perfect blend of science and art. And that, my friends, is how a robot arm calculates its intricate dance of movement. So, we've taken a journey through the intricate calculations behind the movements of a robot arm. We've delved into the kinematic model, observed the choreography of calculations, and marveled at the execution of movements. Next time you see a robot arm in action, you'll know the complex ballet of calculations that makes it all possible. Stay curious, and keep exploring the fascinating world of robotics.